Good morning. I am Dr. Senthil Kumar, a scientist working in the field of hydrogeology from the Central Groundwater Board, Ministry of Jal Shakti. Presently, I am posted in Chennai. I'll be taking you through the use of SkyTEM, that is the Heliborne Geophysical Survey, which is an advanced technique now which we are using in the country for groundwater mapping and for delineation of aquifers. So this topic I'll be taking you through to the next half an hour. Going ahead, why this study has come up, we will just see it in one by one. All you know what is aquifers. Aquifers are nothing but these are the permeable formations which can yield and store water. Okay, so India is the largest user of groundwater. As you know that our extraction is more than the extraction of China and US put together, and this extraction skyrocketed since the Green Revolution, and it went on, and if you see India's graph, it was going something in a 45-degree angle. So government decided that there is a need and we need to move towards a management aspect. So there was a paradigm shift from groundwater development to groundwater management. So in order to have a paradigm shift towards groundwater management, the first thing they wanted to do was first to know the aquifers. So if we know the aquifers, then we can manage the aquifers very well. So with this objective, the National Aquifer Mapping Project was taken up in 2012, and its main objectives were to map the aquifers, both vertical and its horizontal extent, characterize the aquifers, assess the groundwater quality, quantify the recharge and discharge components, and finally leading to groundwater management plans or aquifer management plans. In order to do this aquifer mapping, we took up several integrated studies, which included hydrological studies, geophysical survey, exploratory drilling, hydrochemical studies, then water level, water quality. All this put together, an integrated approach was taken up, and in this we introduced the new technology. This is the advanced geophysical technique, the Heliborne survey, or the proprietary survey of SkyTEM was taken up in this study. So all this put together, we were able to get the subsurface information in a very clear and a very picturesque manner. So we will see how this survey works and how we took up the entire area. So if we see the history of the electromagnetic system, this started about 50 years ago, mainly in the western countries, mainly in the uninhabited places where heavy areas are available. Large areas were covered in a very shorter period of time. This survey started 50 years ago, and these were successfully done in the 1950s for exploration of metals, base metals, and they deployed the electromagnetic survey or the airborne electromagnetic survey, and since all the exploration has completed, they moved towards the groundwater exploration. So if you see in 2000 onwards, this survey is more taken up for groundwater exploration, mapping of the subsurface, to know the subsurface, what is the extent of the aquifers, the extent of the permeable zones, the non-permeable zones, unpermeable zones. All this they took up in the coming years since 2000. If you see this electromagnetic survey, there is a loop. You can see the loop here. This loop depends upon your depth of investigation. If the depth of investigation is higher, the size of the loop increases. Okay, and the components of the loop we can see one by one. We have a transmitter coil in the front, and a receiver coil in the back. So the helicopter flies at an altitude of 30 meters above ground level, and it carries this loop. We have a generator, a motor generator in the center part, and an electronic device to transfer the data, acquired data from the loop towards the base. If you see, this is the extension of the loop. As I told you, if the depth of investigation is 300 meters, then the loop will be around 500 square meter will be the size of the loop. And these transmitter coil and receiver coil are further synchronized with the altimeter. So the altimeter, what it does, if the ground elevation increases, automatically guides the helicopter to move the loop towards the higher elevation, or if we move towards an cavity area or a low lying area, trough area, automatically the helicopter moves towards down. So the 30 meter height of the loop is always maintained. And if you see, this technique is highly usable, and we get a gamut of information. Whereas if we in a drilling, we can drill a well here and another well here, and automatically get the subsurface information, as this is an aquifer and this is an aquitard, a clay. So these kind of information, the subsurface information, through a drilling we get it like this. In this well we get it, and we get in another well. And what we do, we combine these two wells through a geological sense, and we prepare several sections. Whereas when a helicopter flies, it acquires information of all the points at a close interval. It might be 50 meter, it might be 25 meter, even it might be 100 meter. So we get information throughout this area, and automatically what it does, the density of the information is very high. So that leads to higher resolution, and what it leads, accuracy of your data. Moving ahead, so this information is available. In many scales, as I told you. If the depth of investigation is 300 meter, the loop size will be higher. And if our depth of investigation or our objective is for a shallow, then automatically the loop will be a smaller size loop, and it will be either 100 meter, 150 meter, and accordingly the depth of penetration. And based on our experience and several studies we carried out all over the India, we have found good information up to 150 meter. In sedimentary formation, we have got good information up to 150 meter. So if you see, this is the system design. As I told you, the size of the loop depends upon the depth of investigation. If the depth of investigation is very high, then the loop size will be high. So it will be 450 square meter or even 500 square meter will be the size of the loop, and your depth of investigation will be 300 to 350 meter will be the depth of investigation. And what else is there in the loop? If you see, we have a laser altimeter which guides and tells the pilot that this will be the altitude which you will be flying. We have transmitter coil in the front and the receiver coil on the back of the loop, and we also have a receiver device. This is connected through a Bluetooth device, which from where the receiver coil we receive the data, and it is automatically transferred to the receiver coil, from where it is transferred to the base station. The scientist working in the base station immediately analyze the data and they are able to communicate to the pilot that if there is any noise or any data is missed, so that he flies again and covers the entire area. The entire system is controlled by a generator, from where we get the power. And if you see the advantages of the system, no additional manpower is required. Only one manpower who runs the helicopter or the pilot is required, and apart from that there is no other requirement. Only at the time of loading of the cable with the system, a requirement is required. Otherwise the manpower requirement is very low, and large areas can be covered in a very short period of time. And what and all are the components available, I told you, we have a transmitter and receiver coil, power supply, laser altimeter, global positioning system to guide the helicopter of the directions, the electronics, the data loggers, and everything is in a connected to a helicopter. And we also have differential GPS, or as I told you, the GPS, which tells us the altitude at which it flies. And the helicopter fly speed is very low. It flies in a speed of 40 to 50 kilometer per hour. So with this low speed, automatically it is able to cover the larger area in a very short span of time. Moving ahead, if you see the geophysics behind this Helibond survey, as I told you, we have a transmitter coil and a receiver coil. From the transmitter coil, the current is switched on and off. So what it does, it creates a primary field. The primary field, it travels in this direction. As soon as it touches the ground, the switch on and off, it creates as the primary field. As soon as it touches the ground, the eddy currents are created. So what it does, automatically the secondary field is generated, and this conductivity is again received by the resistance, is again received by the transmitter coil, and this electromagnetic is converted into resistivity for interpretation. So as I told you, the low frequency, if our depth of investigation is only 100 meter, we use a low frequency loop, and the loop might be 150 square meter, and the current applied is only 10 amps. Whereas in a case of a high frequency or a high data requirement, where the depth of investigation is very high, where we need to go up to 300 meters to find the subsurface information, which is basically done for the geotechnical work, we do only the shallow case. Whereas in a case of a deeper investigation, we go up to even 300 meter. Our loop size will even be 450 square meter or 500 square meter, and the current application also increases here. It is 110 amps maximum we go, and this is the fly speed. The fly speed of the helicopter is around 40 to 60 kilometer per hour. So the entire system works in a very fast. It travels in a straight line, and several straight lines are again intersected with a perpendicular travel. So what this does is that this data is further validated with surface geophysical method or a detailed exploratory method. We do a exploratory well, we do a take core and validate this data. Automatically the entire fly path or the flight line, we acquire data, we receive a gamut of information. So you can see the information received through the entire fly line. So the entire fly line will have data of the resistivity. So this is how it works. As I told you, this is the transmitter EM signal. As it goes, the size increases, and when it is switched off, automatically the receiver coil receives the secondary field created. So the data will be higher near to the loop. So the information received will be converted into resistivity, and according to the resistivity of the formation, the interpretation takes place. For example, a massive rock or a hard rock will have higher resistivity value from 10 to the power 3 to 10 to the power 4, you can see here. So likewise, in the case of a salt water, the resistivity values will be very low, and we move towards the harder formation. The values of resistivity will be very high. 1000 to 10,000 ohm meter will be the values of the hard formation. According to the formation, according to the quality issue in the formation, we can easily decipher the formation with the help of the resistivity data, and automatically we can decipher the information of subsurface up to a greater depth. We get several informations of resistivity maps or heat maps in several areas. So these maps clearly show us the darker shades are the higher values, the lighter shades moving towards the green or the bluer shades, light blue shades are the lower values of resistivity. In a conductivity, it will be in a reciprocal state. So we get, this is the information available through a litholog, a drill log. This is a drill log. You can put it as a log obtained through drilling, and this is the subsurface information available through a e-log. So these two data will be used for validation. So these are the drill logs, and these are the information available from a SkyTEM. So these data are validated, and once they are validated, we will clearly able to identify which are the potential areas, which are the areas with low quality of water, and which are the hard formation, strata wise hard formation. Once validated, this data is processed. So you can see this is an example of a flight line. These are the flight lines, the green lines you can see here. These are the flight lines in which the helicopter has flown, taking the loop at a closer interval. This interval was about 1 kilometer was the interval, and in several areas perpendicular flight lines are also performed in order to have a more accuracy of the data. So once this is done, these are the processed data. You can see here at a 50 meter, this is the slice available. What will be the information? These are the hard formations. We have some potential areas here. And they at 150 meter, at the depth of 150 meter, okay, you can see some potential areas here. And at 250 meter, likewise, the information is available at different slices according to the interval. If the area of interest or the study area is having more interest, then we can have a 10 meter slice. In this case, we have just explained you about the 50 meter interval. 50, 150 and 200, 250 meter, 100 meter interval. In several areas where we the depth of investigation or our aim is of a different objective, so we go at a 10 meter slice also. This can also be possible through the system. So coming back to our study, what we tried in India was a pilot study, 6 pilot studies in 6 geological terrains. Kadalur formation having sedimentary with sandstone with a coastal area. Then Dausa, it was in Rajasthan, desert condition. Then Rajasthan one more with quartzites, hard formation, quartzites were used. Nagpur we tried with the Deccan Traps, the basalt formation. Patna we tried with the Indo-Gangetic alluvium, 500 meter alluvial formation, pure sand and clay up to 500 meter. Then in Tumkur we tried with the granitic gneiss. So if you see 2 hard rocks, one completely alluvium, this is sand, this is one more type of hard rock, this is the Deccan Traps. Then we had alluvial sedimentary formation in the form of sandstone with a coastal boundary, then a desert. So 6 different terrains we tried this efficacy of this electromagnetic survey and found different interesting results. And based on these results, we have further taken up the entire arid region of the western India, covering from Haryana to Rajasthan, then Gujarat. We are covering about 4 lakh square kilometer, in which the first phase 1 lakh square kilometer results have been come very promising results. We can see here. So as I told you, one study in southern part of India, which is the coastal area with sedimentary sandstone. Karnataka part we had the granitic gneiss. Bihar we had the Indo-Gangetic plain. Then Maharashtra the basalts. Rajasthan 2 studies, one covering the quartzites and other covering the desert environment. So all these studies we put together and we got some very interesting results. We can see these results one by one. So this is the Kadalur area, the sandstone formation, very vast area, large area was covered in a very short span of time. We were able to get flight lines in a closer interval. The flight lines, the closer interval was about 500 meter. The depth of investigation, we tried to acquire information up to 300 meter. So the loop loop size was 450 square meter was the loop size. And you can see, as you can see here, different slices on the left hand side, 0 to 10 meter. This is the area of investigation which is for a shallow investigation. For a basement, if you want to have a geotechnical investigation for a basement, then you can see the data acquired for 0 to 10 meter. Very high frequency data, and a large quantum of data was acquired. You can see this red portions. The red portions are the areas where we have high resistivity, that shows the formation is very hard. And the lower resistivity, these are the areas where we have clay and saline formation. So likewise, we were able to decipher the subsurface information. You can see here 0 to 10 meter, then 40 to 50 meter, 80 to 90 meter, 120 to 130 meter, up to 250 meter. In some areas, we were able to get even the noise. The no data was acquired in some pockets. Otherwise, we were able to get good information of the subsurface. You can even see the slices. You can see the slices here, how the slice looks. Slice up to a depth of 210 meters. You can see here. So the entire subsurface information you can see here. We were able to decipher the aquifer units here, the clay formations with the low resistivity values. All this were completely deciphered. And see, as I told you, these are the information available from a borewell log. So we connect the borewell log, and many areas based on these connections, these are assumed datas. Whereas in the electromagnetic survey, you can see the entire area is captured. So we have data at a very closer interval, and this leads to more accuracy of refining the subsurface. And for further preparation of our management plans, these data were very useful. So the entire subsurface of this area we were able to categorize. We were able to identify 4 aquifer units to a depth of 300 meters below ground level. Within these 4 aquifer units separated by 3 clay layers, and we also have lignite. This is the output of a Kadalur area where we were able to clearly decipher the thickness of the aquifer units, the thickness of the clay layers, and even the lignite occurrence, lignite extension, vertical and lateral extent of the lignite. All this information were completely deciphered. You can see the resolution of this 3D diagram, which was mainly acquired through the SkyTEM process and the electromagnetic survey, further validated through lithologs, and all this formed together our output. So with the help of this, what we got, we were able to get the depth and occurrence of the aquifers, thickness of the aquifers, the vertical thickness of the aquifers, yield of the aquifers, the sustainability of the aquifers, how long it can yield during a summer, during a winter, all this information, chemical quality, aquifer wise resources. Since we know the thickness of the aquifer, we were able to even calculate the resources available, the aquifer wise groundwater quality. In some areas where the fresh water saline water interface was there, we were able to decipher this, and finally the remedial solutions we were able to bring out with the help of this, identify areas of in situ salinity. So what we have with this data, what we do with this data is that we have a 3-tier system. We share it with the State Groundwater Coordination Committee headed by the Principal Secretary, or the ACS nowadays, Additional Chief Secretary, where we share this data, entire data, and along with this data, the line departments are also present during this meeting. And at the next level, we share it with the district magistrates and the district commissioners or the district collectors. At the grassroots level, we organize several public interaction programs, mainly to tell the farmers how much water they have in the aquifer system, what is their yield, what is their water quality, and finally all the data is available in the website of CGWB, and it is completely downloadable. And moving ahead, As I told you, we have taken up next 4 lakh square kilometer to be covered in the arid areas of Rajasthan, Gujarat and Haryana. 1 lakh square kilometer area has been completed. You can see here, this area has been completed, this area has been completed, this area. So we are getting really good results, very good interesting results based on this SkyTem results. And these are the output of Haryana. You can see here, this is an output of the Kurukshetra area. Kurukshetra is a very famous area, as you know about the Mahabharat, and Mahabharatam. This is the area where several battlefields are available, and these are the flight lines of the helicopter. These are the perpendicular flight lines and these are the horizontal flight lines. So the entire data is all along the flight lines. The data is available and we were able to identify these are the areas which are completely devoid of water, and where the areas where we need to recharge the aquifer system. You can see here several sand formations, sand predominant formations have been identified, clay areas have been clearly demarcated. So likewise, this is an output of Kurukshetra area. So all along the flight line, the helicopter flies like this, automatically the data is generated, the subsurface data. The data is interpreted using validated and interpreted using the litholog information or the borewell logs. And once the data is interpreted, we have what this does, we have also identified areas for managed aquifer recharge, areas where we have potential aquifers, paleo channels. Paleo channels are old channels where now few channels we have identified where there is no water, and other areas where there is high potential. So these areas have been identified, clearly demarcated the sand formations and the clay formations. So this information is completely passed on to the farmers. So in a village, for example, a village is lying on top of this, the farmers need to drill only up to this depth. So the depth of drilling will be only 100 meter. They need not drill beyond that because there is a very thick clay formation. So these kind of information are passed on to the farmers through an information system, India Waris information system, where the data is completely available and it can be downloadable. So this is an output of Chiru area. Chiru area, as I told you, as we fly, this is a zoomed out area. So you can see here, as the helicopter flies in this direction and this direction, we get subsurface information in the form of a fence diagram. So the entire area is complete. We have a gamut of information, and the entire area is completely, we know the subsurface information, the vertical and the lateral extent of the aquifers, the subsurface information, the aquifers, the aquithards, all the information is completely available. You can see here. So entire this area we were able to clearly demarcate it. This much of area is affected by saline water. So we need not drill in this area, only the information you have to drill only in the shallow formation. This is the only formation available for you. So likewise, information was passed on, information of paleo channels. All this information is completely demarcated through the electromagnetic survey. So likewise, now as I told you, we can get information through fence, we can get information through slices, we can get information through 3D diagrams. So subsurface slices, these are the slices at different depths, 0 to 10 meter, 40 to 60 meter, 60 to 65 meter, different depths according to your interest. Whatever you want, you can get it. Further, you can get slices, different depth slices, then you can also get a 3D diagram. So this is one information of the basalt, the entire Rajkot area, where the helicopter has flown in these directions, and we are getting information of the subsurface. So these are predominantly massive basalts. There is no fractures in it. We were able to clearly demarcate. You can see here we have identified areas of areas favorable for managed aquifer recharge. So if you recharge here, automatically we have a weathered formation which is completely devoid of water. So automatically the intake capacity will be very high here. So similarly here also there are areas where area is devoid of water, this area. So likewise this information was been passed on to the district collectors as well as to the line departments. So automatically this data is now being used. So these are, as I told you, we have identified several paleo channels. This is an area from Bilara, Rajasthan. You can see here the areas where you can have high restivity and low restivities, and automatically area suitable for MAR areas, managed aquifer recharge. We have identified several locations. These locations with the lat long is passed on to the state departments. We get the lat long exact geotagged coordinates. Geotag coordinates are passed on to the state departments or the line departments, then to the rural department which does the Manrega work, MG Narega work, where large activity of recharge is taking place. So entirely they go and drill in that area. They do the shaft, whatever structures, recommended structures, surface structures, subsurface structures, all this information are passed on to the line departments. Another interesting thing, what we have identified, the helicopter had flown in Prayagraj area in Uttar Pradesh, where we have identified a very long buried paleo channel, and its extent is about 14 km long, 4 km wide, and a thickness of 15 meter. It is occurring at a depth with a soil cover of 10 to 15 meter. What now we are doing is that we are now taken up a detailed study. These are the paleo channels where we have identified. Now we have taken up a detailed study for storing water in those paleo channels and using it in a lean period. So we are now trying to use this as UTFRR, underground taming of floods for recharge and recovery. Underground taming of floods, where during floods we have high water. In this paleo channel we are just storing it and using it for recharge and recovery. All our diagrams which were earlier in 2D, something like this, have now changed to 3D. You can see the subsurface information, this entire subsurface information, which are the aquifers. These are the aquifers, potential aquifers. These are the areas where there is saline water. These are the areas where there is brackish water, the information of fresh water. All this information are now captured because we are getting high resolution data through the electromagnetic survey. So thank you so much for your patient hearing. For any information you can see our website. All the data which I was talking about is available in the website, and for further information, if any other information is there, you can email to me. I will be happy to reply to you. Thank you.